This video is brought to you by YTAndrewPaul Tech Repairs. If you have a console, laptop, computer or Macbook in need of repair in the UK or the EU, then have a look in the description below this video for details on how to contact us in order to organise your repair. Hello there ladies and gentlemen, and welcome to today's video. And today we're going to be taking a look at this SAD001 revision motherboard from a PS4 Slim. This particular board has a no disk feed issue, so when you try to feed a Blu-ray disc into the drive, there's no activity. Now this particular board is an interesting one because we've done a previous video on these boards where there is a fuse, F6202 I believe, that blows, and I'll put the link to the relevant video in the description for you. I'll just find that area of the board there, but essentially it's just here. It sits just to the left hand side of the Renesas with it nearest to you, and those are the two fuses in question: 6201, which is there, and 6202. 6202 is typically the one that goes on this particular board. These two fuses are completely intact. The drive is good. Put it in a different chassis with a known working drive, absolutely fine. No issue there. 6202 fuse is good. 6201 is good. 5103 is good. 5103 is further back. That's just here. So basically, all these fuses test absolutely perfectly well. On the underside, of course, we have F6001, which is there. That's good. This R330 is perfectly fine. Yes, so there's a few different bits and pieces on this board which you can check, and obviously in this particular instance all ours are absolutely fine. There's no issue whatsoever. Drive motor controller was exchanged. That is the BD-ROM I do believe on these particular boards. That was fine. This here, this little microchip 3536C, if I remember rightly, this here has been exchanged. Again, yeah, all absolutely fine, no problem at all. No change to the issue at all. So yes, in that particular instance, it's been a while since I've had one of these boards, and certainly not. I've certainly not had one to take a decent look at until now, really. And this is sort of one of those videos I wish I didn't have to make because it's kind of bad news. But I know there's been quite a bit of debate recently with regards to techs in the sort of sector, looking at these things as to, you know, is it a Renesas issue? Is it not a Renesas issue? I know I've previously looked at a few of these where the fuses have been good, but I've not had that long to look at them, to be honest with you. They've been really quick, but that's the sort of quick thing I came to the assumption of, it was the Renesas. But I know some people, you know, sort of dispute the fact that it's the Renesas, but it's been a while since I've had my hands on one, sort of have another look, and having had a look at this one, I'm fairly sure it's the Renesas that's buggered, unfortunately. And in that case, there's nothing you can do because the Renesas is a per box component. It's unique to every single PS4 the world over. Unfortunately, you can't exchange it. So if that chip dies, your console dies with it. And unfortunately, I have come to the conclusion today that where those fuses are good and they're intact, the board itself is good, the Renesas itself is bad. And let me tell you why I've come to that conclusion. Okay, so when I had this board here, there was a few different things that I was testing. So obviously, I wish I'd kind of recorded it as I was doing it. It would have made a really interesting video. But I'm sort of having to remember bits and pieces, so hopefully I can remember this in the right order that I did it. Okay, so essentially coming along here we have the disk drive connectors. Okay, we have this one here which goes to the switches at the back for the disk detection. There's 1.4, 1.5 volts on these test pads here. That's absolutely fine. Up over here, I think is the spindle motor and stuff like that. There's around 3 volts ish on these pins. Again, all that voltage wasn't initially there actually. I exchanged the motor controller IC, the voltage then came up on here, and that was all okay. So we've got the relevant voltage here. I've tested this against a working board as well. All these readings have come against the working board. And unfortunately, like I said, you know, as I've started getting somewhere and you think, oh, I've got a little bit further than I was before, unfortunately it's about to smack me down in a minute. Okay, so I have the voltages on the rear switch ribbon. I've got voltages on the spindle motor and stuff like that, and the front switches. So then I came to the middle connector here. So this is the one that goes to the laser sled and the laser mechanism and stuff like that, the worm feed motor. So this is a bit of an interesting one. So of course here on pin 2, on the top side of this top side of this capacitor here, you should have around 5 volts. Okay, now I was getting 5 volts there. Okay, the issue I was having was here. Okay, so on this test point here, with no disc in will read 0, with a disc inserted should read 8 volts. Now I wasn't getting anything at all. Okay, so coming across here, you should have around 2.5 volts on this pin with a disc inserted. With no disc inserted, there's nothing there. And on this little capacitor here, on the right hand side of it, there should be a reading of around 5 volts with a disc inserted and present, 0 volts when there isn't. Okay. Now then, the only thing I was getting was 5 volts at that first capacitor there on pin 2. That's all I was getting. I wasn't getting anything else at all. Manually fed a disc into the drive, still wasn't getting anything. Okay, so I changed a few different pieces. So I came down here, did some continuity checks on the traces and things, and it seemed that a lot of it came back to this microchip 3536C. Okay, now I've exchanged that with one from a donor. The donor itself had a completely different issue. It was BLOD. The disk drive did work absolutely perfectly fine. Unfortunately, that didn't alleviate the issue at all, which was a bit of a shame because it would have been nice if it had. But no, alas, that wasn't the case. We still weren't getting any sort of readings of voltage on those various bits and pieces up by the laser connector, by the sled connector at all, with a disc inserted. Okay, so essentially what I did is I went on a bit of a wild goose chase and I stripped back the conformal coat here on this pin, which should read around 8 volts with a disc inserted. Okay, now I wasn't getting anything there at all with the disc inserted. It turns out that there is connected to here. Okay, it's connected to these 2 pins here, just up here. 3rd and 4th in from the top on the right hand side. It comes across this capacitor and then it goes out through here. Essentially that goes sort of top side of the board. Okay, now I was wondering actually, because I was missing a few different bits and pieces. Like I said, I was missing the roughly 2.5 volts here. I was missing the 5 volts from here. Now it turns out they all come from this chip. Okay, so then I'm thinking, well, am I getting power? Am I getting power to the IC? Well, I knew I must have been because I was getting sort of like 12 volts and 5 volts from these large capacitors here, and indeed through here I was getting around 1.2 volts, which comes into these bottom 2 left and right pins. So the chip was getting voltage, it was getting power, it was outputting what it should do, but something was pulling this line low, and along with the rest of these. Okay, so anyway, what I decided to do then was do a little bit more investigation, and on a working board here, pins 2, 3, 4 and 5 on this bottom left hand side of this chip. Okay, so pin 1, as I say, is voltage in, so that's 1.2 volts in there. Pin 2, I think, is some sort of signal from Renesas. Pin 3 and pin 4 from the bottom left are 3.3 volts. Now I wasn't getting 3.3 volts there either. I was on pin 4, but on pin 3 I was getting like 0.1 of a volt. Okay, so again, something not quite right there. A non-working board has 3.3 volts on both those 2 pins. Okay, so there's 2 test points for those 2 pins, just here and here. As I say, top one was giving me 3 volts, 3.3 volts. This one here was giving me 0.1 of a volt. So there was obviously something not quite right there. So anyway, coming back to this here, and this 8 volt pin here. So it comes out from this IC. Okay, so I was wondering where the hell this comes from. So essentially what I did was I wanted to know what sort of sparked that off. What gave it the signal to start generating that 8 volts once that disc is inserted. Okay, now as I say, remember, I wasn't getting anything with the disc inserted or anything else of that nature. Oops, my apologies there. So yes, so what I wanted to know was what caused that 8 volts to trigger. What begins the output there? What causes that chip to drive 8 volts to that pin? And as I say, the only thing I could work out at this point, when I knew the chip had power and it was doing more or less what it should do, as I say, when I checked against a known working board, the only thing I could see as an anomaly in this area was this bottom test point here. And that bottom test point, I do believe, goes to pin 3 up from the bottom left hand corner. I think it goes to this pin here, if I remember right. You can just about see the trace underneath that flux there that goes to this pin. It then goes through this via, okay, and then from that via it goes top side of the board. If I can find you, let's see if I can remember where this comes out. It comes out of here. Yes, it does. So it comes out across this trace. Okay, it comes down here and then it disappears down this via. And then you're wondering, well, where the hell does it go from there? Where it goes from there, and I'll see if I can dig out my donor board, because I think it was the donor that I used to try and work this out. Indeed, I think it was. So this is the donor board. It's the same SAD001 revision as the one that we've been working on there. So you can see I've just about scratched that test point, that via back there, okay? And that goes, and I will see if I can get the multimeter out just to jog my memory on this one. Okay, put it into continuity mode. Put one probe on that test point that I scratched in, and it comes to pin 6 from the corner here, fairly sure. Hopefully you can hear that. So it basically comes up this via here and onto the 6th pin. Okay, so that was a little bit weird. So I was like, okay, well, is it just that the pin isn't driving 3.3? Is it an input or an output? So I wasn't sure at that point. So what I did was I popped pin 6 off the board. Okay, so I just lifted it up. Okay, so I lifted pin 6. Okay, so you can just about see there, hopefully, that it's not there where it should be. Okay, you can just about see there that it's, try and get it front on. It's kind of awkward to try and do this under the scope, but hopefully you can see that. Oh, well, it's coming across on camera, but anyway, pin 6 is lifted up. It's no longer connected to the board at all. It's lifted up there. It's no longer connected at all to the circuit. It's completely out of circuit. So we lifted pin 6 from there and then fired the board up. And guess what happened? As soon as I did that, I started getting 3.3 volts again back on this pin. Once I'd got 3.3 volts there, I was getting 8 volts out of here. I was also getting 8 volts here on this on the left side of this cap and this pin, because of course it's all common. I was still getting the 5 volts there, and I was also getting 5 volts here then with a disc present. So I'd actually solved the biggest part of the voltage issues. What I hadn't solved was this, where there was 2.5 volts. There's 2.5 volt point here. Okay, so what I did was something similar. So I tried to work out where this was coming from. Okay, so what in the end, where it turns out that comes from is further up here, and that comes from, if I can find you, that essentially comes into here. Okay, this comes into this point here, and from that point there, it comes in from the Renesas to this pin just here where you can see my tweezer blade. Okay, it goes down these two vias. Okay, and then from there, it goes bottom side again, and there's a little capacitor, tiny capacitor that sits here. Okay, it goes across there. Now, what I found again there was, okay, so I popped the capacitor off just to see what had happened. I squirted 2 volts into there, it was holding at 2 volts. However, what would happen then is whenever there was a 2.5 volt signal here, it would actually start driving some of these other voltages low. So I'd start losing voltage here. This would start to become 0.1 of a volt. And there was also something else. Oh, that was it. The disk sense, the switches on the rear, on this connector here, the rear drive switches for the disk sense, those also started coming low to about 0.1 of a volt. As soon as I removed that external voltage, yes, the 2.5 volts dropped from here, and these then, when I rebooted the console, came back up and they were behaving as they should do. But obviously I didn't have anything here, or even though I had everything else, the drive itself was still completely dead. Now, the Renesas must be functioning to some degree because it knows when there is a disk in the drive and when there isn't, because when you hit the eject button, the thing will beep once when you have a disk inserted, and it will beep 3 times when you have a disk ejected. But for whatever reason, some of those other pins that are driving this circuit are dead. They're no longer functioning as they need to do. Now, I've tried a few different things, nicking voltage from other various bits and pieces. Like I say, I've been squirting it in my external bench supply just to see if I put voltage there with it not coming from the Renesas. Does it work? The answer is no, it doesn't. So there is something on that Renesas IC that is dead. There is something that is killing that chip, and I'm not entirely sure what it is or how it's doing it at this point. But I do know now, I'm fairly comfortable to say, having spent the last sort of 3 or 4 hours looking at this board, just for my own curiosity, really more than anything. I knew I weren't going to get it working, but I just wanted to know, exactly what the hell's going on. Can I trace this back at all to the Renesas? And as soon as I lifted that pin, as soon as I lifted that 6th pin in from the left-hand side there, as we have it orientated on the video, and all these voltages came back, I was happy that the Renesas itself is in some way internally shorted, and that is the problem. So unfortunately, ladies and gentlemen, it's a video I hope I didn't have to make, and usually, to be honest, I think this may be the first video I have on the channel where I haven't managed to fix something. I think this may be the first one I've uploaded, which has been bad news. I know we always have a good outcome. I know that I like to show you things, working through from start to finish and how you can correct an issue and actually show it working at the end. But unfortunately today we're not going to be able to do that. And the reason for that is because the chip itself is dead. Now why it dies, as I say, I honestly don't know. I haven't been able to work that one out, what's killed this particular one. I do know it's bloody annoying, and like I say, it's a video I really wish I didn't have to make, and I wish I had a magic answer for you. And the same with the community, because like I say, I know there's quite a few techs out there like myself that came to the conclusion it's the Renesas, and you've just as many the other side going, I can't really see the Renesas being the issue. Surely it just won't read. But unfortunately, I think coming off the back of this, there's no other conclusion that I can come to which says anything other than the Renesas. So it's unfortunate, but there we go. So hopefully, as I say, if somebody else wants to pick this up and run with it, and see if they can work something else out, or if I've sort of sparked an idea in somebody's head to, well, maybe you're wrong, but that's given me an idea to check this and this. Maybe we can, then fine, great. As I say, this is just a start for 10. Hopefully, it can kick somebody else to take a look into this and see if it's the same issue on their boards, or whether they've got an idea as to what might be causing it. But I don't think there is, unfortunately. I think it's bad news, and I think, to be honest here, we've proven today that it is indeed the Renesas that's at fault. And unfortunately, as I say, because that's a per box component, there's no way you can do it. I mean, if you had a scrap board, you can start doing stuff like doing full BGA swaps with APU, Syscon. You'd have to take the Renesas, NOR. But why the hell would you do that? It's misery. And to be honest, surely it'd just be easier to fix the board in question than it would be just to nick all the chips to put on a donor PCB like this. It doesn't really make any sense. So unfortunately, it's not really an economical thing to do. Certainly not, if you've got a faulty one to send away for repair, because most repair places are just going to tell you to bugger off. So it's a bit of a shame. As I say, it's a video today I hope I wasn't going to have to make. I was hoping, when you spend a couple of hours on something, you're really pushing and probing and you get a little bit closer. Once I got all those voltages back on that connector, even though I'd have to pop that pin, and that was in the back of my mind thinking that surely is going to be a problem. Yeah, it was a bit of a problem, unfortunately. It really pains me to say, but I can't fix it. This one is dead, and it is the Renesas at fault. And I suspect that I haven't got any more in here with this same fault where the fuses have been good. They're long gone back to their owners, unfortunately. But next time I get one in, I'll just check the same thing, and I'll pop that same pin up, and I bet those voltages come back. And if so, then it's obviously looking like a bit of a pattern. So yeah, I don't know if anybody else has got any out there and they want to just try that and just see what happens and see if they've got the same voltages at the same places as I do, and whether popping that pin does make any difference. Then yeah, it'd be interesting to know, because like I said, then we've got a pattern of behaviour. Whether we can, whether there's anything we can do to stop it, I don't know. Like I say, we don't have any data sheets or anything like that for these custom ICs, and it's really bloody annoying, because if we did and we had the electrical characteristics of the chip, then maybe there's some sort of overvolt or something like that that's blowing some of these um, internal circuits or something like that. Maybe you remember, harking back to the days of the old PS2 Slim with the ComSoft fixers and stuff like that, the little diode boards and stuff you could get. Maybe there'd be some scope to do something like that, but unfortunately, unless we can work out what the bloody hell's going on, it's not going to happen. So, but it would be cool to find out, because there's a lot of these machines dying in this way, and unfortunately, if they're all buggering up to the point they can't be repaired without exchanging that chip, and of course, dare say Sony can change that chip. Because they're Sony and they've probably got access to all the coding tools and everything else, they need to reprogram the boards and reprogram that particular chip to that board and get all the per console keys and everything and burn them back together so everything ties up. Then great, but obviously we don't. So to us, this is knackered and fit for nothing but parts, which is a real shame. So thank you very much for watching, ladies and gentlemen. Unfortunately, today I've not been able to give you any good news, but what can you do? You can't fix them all. As I say, it may be very good in independent repair with these sorts of things, especially because, as I say, with no schematics or anything to go off, it's purely off your own investigative, logical thinking. But we're not witch doctors. We can't fix everything, and we can't fix them all as hard as we try. And by God, I've tried with this one. But fortunately, I've satisfied myself that it is indeed the Renesas. So yes, thank you for watching, ladies and gentlemen. Hopefully you've enjoyed it. If you have, feel free to pop a thumbs up down below. Give the video a like. It really helps with the YouTube algorithm to show that more people, more people are enjoying it, and therefore it shares it out to a wider audience. More people can hopefully then see it, jump onto the channel, really like what they see. We're all being well, hopefully, and we get a few more subscribers. The channel grows, and I'm incentivized to do some more videos. So yes, thank you very much for watching. As I say, it's a shame we've had bad news today, but can't do anything about this one, unfortunately. So thank you for watching. Hope you've enjoyed it. This PlayStation has been a nightmare. You've been fantastic as always. I've been Andy Paul, and I'll see you on the next video in the not too distant future. So from me for now, it's bye-bye, and I hope life treats you well, because it hasn't treated me well here. Bye-bye. Many thanks for watching then, ladies and gentlemen. Hopefully you've enjoyed this video. If you have, then why not check out these recommendations below. Also, please remember to comment, rate, and of course subscribe to the channel if you found this useful. We've plenty more content on there, and there's lots more to come.